Okay, so slope-intercept form is the way we want our equations. In A and B, graph and solve the system, then we're going to answer A and B below. Okay, so if we look at our equations, you see the top one is in slope-intercept form? So let's just graph that one. So my slope is 2 over 1, and our y-intercept is -1. So let's go to -1 and put our first point. And then, since my slope is 2, I'm going to go up 2 spots, across 1. I'll just do a couple of those. Oops. I made a mistake there already. I had to go up 2 over 1. There we go. I'll do 1 in the other direction. So there, I got 4 points. Line them up. And graph. Okay. What do we have to do to this second one? This other equation. It's not in slope-intercept form. Yeah, right. Yeah, eventually divide. Before we do that, let's move over -4x to the other side. Oops. So what's going to happen when I move it to the other side of the equal sign? Becomes positive. So my new equation is 2y equals -4x equals 4, or plus 4 rather. So all we did was move it over, and it's positive 4x. Positive 4x plus 4. And now we divide. So let's divide away 2 to every term. Okay. And it cancels here. We get y equals 2x plus 2. Okay. So now let's plot this. I'll use a different color. How about green? Okay, so now we're graphing this one. And so we're going to cross at +2. And again, same slope. Up 2 over 1. I'll do a few more points down to the left one. What kind of lines do we have? Parallel. Same slope, different y-intercept. That's all we really need to know to see that they are parallel. Okay. So we'll talk about what that means in a little bit. Let's graph the other. Let's go move over to B, and our y-intercept is -2. And what's our slope? -1 over 1, yeah. If it's -1, which this is, then it's down 1 to the right 1. I'll just do a couple of points the other way. So here's our slope. -1 goes through -2 on the y-axis. There we go. Okay. Let's do the same process for, yeah. Sorry. So let's set this other equation equal to y, bringing over 6x. So now we have 6y equals, what's on the other side of the equal sign? Well, if I bring the 6x over to the right, it goes from positive to -6x minus 12. Okay. And let's divide by 6. Okay, so y equals negative 6 divided by positive 6 is negative 1x minus 2. That's interesting. What are we going to get here? We get the same. All right. How would you describe this? The two lines are like the same or overlapping. So now A and B say, what did you notice about the lines in A? Well, obviously, what are they? Parallel. Now let me introduce the fact that, remember we said in a system, the solution is where the two lines cross, intersect. Are these going to intersect? So how many solutions are there? 0. So this is what a no solution is going to mean in a system. You have two parallel lines. Okay. So here we had a system with two equations. Turned out they overlap. How many? Yes. Infinite solutions. There's an infinite number of points that are touching. So lines overlap. Sometimes they say coincide. So infinite solutions. So we have an infinite number of solutions there. So that's the three possibilities. We can have one solution, and that's going to happen when the lines have different slopes. And intersect at one point. So if the slopes are different, you're going to have two lines that intersect. You could have no solution when the lines have the same slope and different y-intercepts. They do not intersect. In other words, they're parallel lines. So this is important, guys. When the lines have the same slope and different y-intercepts, that's when they're parallel. And this case is when you have infinite solutions. Infinitely many. So lines have the same slope and same y-intercept. I'm going to underline that or highlight that. So before you even graph, you can tell right away. If the slopes are the same, then the y-intercepts are different. Parallel lines, no solution. If the slopes are the same and they have the same y-intercept also, the lines coincide or overlap in infinite solution. So let's see what we have in this next example. So I'd like you to try to graph these two. Let's fix this one though. Bring the x term over to the other side. And we're going to get y equals, what are we going to get? Y equals negative x plus 7. Okay, so go ahead and graph these two lines. Okay, so go ahead and graph these two. This one and this one. Okay, I'll give you some time for that. I saw that they intersected at -4, -6. So we have one solution. Okay, so I want you to flip this over to the backside. And let's start with number 3. I'd like you to work on number 3 with your table partner. Let's see here. Let's see. Yes, that's what I was going to say. Lexi, I'll give you your choice. You can work with Juan and Kathy or Manny and Sarai. You can move if you want to. Okay. You realize, or you get the same equation, same slope, same y-intercept. So the lines overlap. So what's our conclusion here? Infinite solutions. Okay. Number 4, I'd like you to work on that one with your partner. The graph line below represents an equation in a system of with no solutions. Write a possible second equation in the system. Okay. If it's a no solution, what kind of line should we see? Parallel. So remember what we learned about especially slopes of parallel lines. And come up with a second equation and line that would be a no solution. So just so we're clear, what is unique about the slopes of parallel lines? They're the same, but in different y-intercepts. So basically, you want an equation with the same slope, different y-intercept. Okay. So start with finding the slope. But I chose, well, I have to have -1/4 as my slope, but I chose -3 as the y-intercept. So you could have had anything except 3 as the y-intercept. So here's my equation and my line. Okay. We'll do 5 and 6 and then call it, and then we'll get to the assignment. So work on this one. Number 5, Tish believes that the linear equations shown do not have a solution because they do not intersect. Do you agree? Explain. So check with your partner, and do you agree or disagree? Make sure you use what we've learned about no solution. All right. So is it a yes or a no?
No.
Because, what's the because? Mm-hmm. Lines go on for infinity, so eventually they'll cross each other. Very good. So we could say that. Did anyone have an answer with the slopes? Did anyone have an answer using the slopes? Yes. Yeah. In order for them to be no solutions, we need parallel lines, so the slopes would have to be different, which they are. One's positive, one's negative. So either one. Eventually, if you extend the lines, they are going to meet. Or in order to have a no solution, you need parallel lines which have different slopes, but these are not. Okay, the last one we're going to do is this one. Circle the names of the two students whose equations would have infinitely many solutions. Explain your choice. So to have infinitely many solutions, what do the two equations have to be? Yeah.
Do they have to be positive?
Well, they could be positive or negative. They have to be the same. Right now we can't tell because they're in standard form. So why don't you convert each of these into slope-intercept form, and you should have two that are the same. So right now they're hiding. But once you rewrite it in slope-intercept form, you'll see that two are equal. Mm-hmm. I went ahead and I quickly did rewrite them in slope-intercept. So do we have a pair or two people that have infinitely many solution equations? Who and who? Yeah. If you graph them, they'll coincide. All right, guys. So today's assignment is a delta math. There's 10 systems that you have to graph and find the solutions. Yes.